In this video, we're going to take a look at lung volumes and capacities, and we are more specifically going to be looking at humans. Lung volumes can be measured using a test known as spirometry. And this is a test, as you can see in the picture here, where the patient has a clip on his or her nose, and this is to prevent air from entering or leaving through the nose. And the person takes a deep breath and then they blow out through this tube that is connected to a computer. And as the person inhales, a graph is formed. So as the person inhales, the graph is going to go up. As the person exhales, the graph goes down. And it measures how much air is moving in and out of the lungs during these inhalation and exhalation events. So let's take a look at some of the different volumes that can be measured using a spirogram. And a spirogram is just what this graph is showing here. And along the x-axis, you would have time. And on the y-axis, you have the lung volume in milliliters. So this would really be air volume. So if we look at this graph, the first volume we'll talk about is the tidal volume, which is in this yellow area here. And so a tidal volume is just the amount of air that is entering and leaving your lungs when you are at rest, just breathing normally. And you can see that on the graph here. It's kind of this up and down area here that you can see in this yellow area. Now, let's say, for example, you take a really deep breath. Maybe you're getting ready to blow up a balloon, or maybe you're exercising, and so you need to have more air in your lungs. That's where the inspiratory reserve volume comes into play. And that's going to be found in this kind of peach orange area here. And so essentially, this is just more area in the lungs that you don't really need to use when you're just sitting there casually breathing, but you have this extra volume available if you need it. Along with the inspiratory reserve volume, there's also the expiratory reserve volume. And the ERV is just the amount of air that can be exhaled after a tidal exhalation. So on this graph, it's going to be made up of this green area here. And so this is the area kind of below a tidal exhalation. So a tidal exhalation would be this area in yellow. And then the expiratory reserve volume is this extra exhalation that you can, or this extra volume of air that you can push out of your lungs. And the last volume on the list is the residual volume, which is this area in purple. And this is a volume of air that stays in your lungs. You cannot voluntarily push this air out of your lungs, and it serves a purpose. It actually helps to keep your lungs kind of partially inflated so they don't totally collapse in on themselves. Now, if you've ever had the wind knocked out of you, so maybe you've had someone hit you on the chest, or you've fallen and you've landed, kind of flat on your back, and that feeling of having the wind knocked out of you, that is a situation where something has happened that has pushed some or all of that residual volume out of your lungs. And it's a really unpleasant feeling because it feels like your lungs have collapsed. The good news is you can inhale and just get that air back in there, but it's not a pleasant feeling. On the previous slide, we were talking about volumes, so the amount of air in different kind of aspects of the lung. On this slide, we're going to talk about capacities. And you'll notice that each one of these capacities it can be calculated by adding up two or more volumes together. So first, let's take a look at the vital capacity. This is the maximum amount of air that can be moved in or out of the lungs in a single respiratory cycle. And a single respiratory cycle is just one inhalation plus one exhalation. And you can see here that our vital capacity is just the addition of the tidal volume, inspiratory reserve volume, and expiratory reserve volume. So your vital capacity is essentially this area here. And this is basically the volume the volumes in your lungs that you have voluntary access to. So remember, kind of a normal sitting there not doing anything, you are doing tidal breathing. But if you needed to, for example, if you're working out or you needed to blow up a balloon, you could tap into these inspiratory and expiratory reserve volumes so that you can take in and breathe out more air. The inspiratory capacity is the volume of air that can be inhaled after a tidal expiration. And so that's going to consist of the inspiratory reserve volume plus the tidal volume. So you can see here, so if you were to do a quiet exhalation and then try to take as deep of a breath as possible, that's going to be your inspiratory capacity. The functional residual capacity is the volume of air remaining in the lungs after a tidal expiration. So a tidal expiration is going to be at the bottom of this yellow area here. And so the FRC is going to consist of the green area and the purple area. So it's going to be the expiratory reserve volume plus the residual volume. And then the total lung capacity are going to be all of the volumes added together. So the total lung capacity is going to consist of the inspiratory reserve volume, the tidal volume, the expiratory reserve volume, and the residual volume. And here's just another look at that graph. It has the volumes already labeled on it, but remember that you can also add in the inspiratory capacity, the vital capacity, the functional reserve capacity, and the total lung volume. So I mentioned that spirometry can be used to diagnose different diseases associated with the respiratory system. So some examples of diseases that can be diagnosed with spirometry includes asthma, chronic obstructive pulmonary disease, also known as COPD, pulmonary fibrosis, which occurs when the lungs and the airways become very stiff, emphysema, which damages the alveoli, so that decreases the surface area available for gas exchange, and chronic bronchitis. And these pulmonary diseases can reduce the rate of gas exchange based on changes in either compliance or resistance. Compliance refers to lung elasticity, so how easily do the lungs stretch and rebound. Resistance refers to the diameter of the airways and whether or not there is an obstruction of the airways. So pulmonary diseases can be classified as either restrictive diseases or obstructive diseases. So restrictive diseases occur when the airways or the lungs are less compliant or less flexible or less elastic. And we can also say that they are stiff or fibrotic. So as I mentioned, pulmonary fibrosis occurs when there is damage to the lung tissue. And there are different environmental factors that can cause pulmonary fibrosis to occur. You've maybe heard of black lung, which was something that was really common back in the kind of the early days of coal mining, where the miners would inhale coal dust, and that dust would kind of like coat and damage the inside of the lungs, making it harder for people to breathe. A more modern kind of problem. I mean, coal dust is still a problem in some areas, but silica dust can also cause problems. I actually have a family friend who worked in a factory where silica dust was used to coat paper. And over, years and years of working in this factory, he inhaled silica dust and it damaged his lungs. And he ultimately needed a double lung transplant. There are some medications that can lead to this fibrosis. Other diseases and disorders might cause this to occur as well. So scleroderma is a disease or disorder where the tissues in the body become hardened, and so that can also affect the lungs. And things like smoking, so the chemicals and the tar in smoking or cigarette smoke and other smoking can cause damage to this as well. Vaping is also dangerous and can cause pulmonary fibrosis. And what happens with these restrictive diseases is that the intrapleural pressure, so this is the pressure in the pleurae, so basically the serous fluid between the visceral and parietal pleura, this pressure is more positive than normal. And so what happens is when someone tries to exhale, the airways actually collapse and it traps air in the lungs. And so if someone can't effectively exhale, it means that they also can't effectively inhale because they haven't been able to get the kind of deoxygenated air or carbon dioxide rich air out of their body so that they can then take in the oxygenated air. Obstructive diseases occur when it's harder for air to get in and out of the lungs or for gas exchange to occur. So 2 examples here. One is emphysema, which this is a disease that occurs when someone is a long-term smoker, and the tar and materials from the smoke can damage the alveoli. And damaging the alveoli decreases surface area, so there's less area for gas exchange to occur. So someone could take a deep breath, and take that oxygen into their lungs, but there isn't as much surface area for that oxygen to actually get into the bloodstream, or for the carbon dioxide to get out of the bloodstream and back into the lungs to then be exhaled. And then asthma, so environmental factors can trigger inflammation in the airways. And so the airways can become constricted and the diameter decreases. And this reduces how quickly and efficiently air can move in and out of the lungs.